Cool.
Last time I took so many notes, I ran out of paper, so I'm well supplied today.
Started.
Wonderful. All right. Last time we took too many notes, but this time we're back for another episode of Continuous Discussions, the online forum where we talk about Agile, DevOps, and continuous delivery. I'm Sam Fell.
And I'm Anders Wahlgren. Today we're doing DevOps for databases. To release more frequently, you want to extend DevOps practices to the database tier, treating it as an integral part of your automated delivery pipeline. But databases are different from source code. They have state and pose a lot of unique challenges to continuous delivery. So today we're going to talk about some of the challenges for building, testing, and deploying database changes, and talk about some of the patterns and best practices for reliably deploying databases as part of our CD pipelines.
And as always, we have a fantastic set of panelists joining us today to talk about this. Brady Bird, please introduce yourself. Welcome to the program.
Hello, everyone. I'm Brady Bird, not surprisingly, since I was just introduced as Brady Bird. I work as a solution engineer with DB Maestro.
Wonderful. Well, we're happy that you joined us. Welcome back to Himanshu. How you doing?
Yep, I'm pretty good. Thank you for having me here today. So I work for AdTech. I'm the CTO at AdTech, and we work in the DevOps and Atlassian tool implementation space.
Wonderful. Well, it's great to have you back again. Pete, our professional panelist, welcome back.
Thanks, Sam. Good to be back on. So my name is Pete Grant. I'm a solutions architect for Cloud BI. We specialize in delivering business intelligence and data warehousing solutions in the cloud.
Wonderful. It's great to see you again. And last but not least, Robert Reeves. Welcome.
Thanks, man. Yeah, I'm Robert Reeves. I'm CTO and one of the co-founders over at Datical. Prior to that, I was CTO and co-founder of another DevOps company, Furnace, which was acquired by BMC. And this is a problem space that is near and dear to my heart because I'm a recovering release manager. Prior to calling it a DevOps engineer, we called it a software configuration manager.
SCM, yep.
Yep.
So I'm interested, what's a Hubby Badger?
Well, it's a nickname that my wife gave me, Honey Badger. So when she has a problem, I make it go away. And that's her cute little name for me. Same thing I do with databases.
Very nice. Make the databases go away. I like that. All right.
Well, the problem. Can't get rid of the database.
I kid. All right. So let's jump in. We got a great episode with lots of experts on the panel. If you are out there listening in and you'd like to join the conversation, be heard. Join us using the hashtag C9D9 for continuous discussions. Let's go ahead and get started. So what makes databases so complex? And I will start with Robert. What are your thoughts? What makes the database such a complex part of this whole process?
Well, look, you look at Conway's law, right? This idea that systems will be designed following the lines of communication of a company. And for too long, we have had these islands of technical expertise. We had the UX folks, we had the business logic Java folks, we had DBAs. The UX stuff, the app server stuff, Java, microservices, we can blow them away and recreate them, the new version. The database has state, so you can't just blow it away and recreate the structure without losing the data. So managing change in a way that doesn't impact the data is very problematic. Combine that with the cultural issues with these silos, creates a really difficult problem. So it's a problem from a tech perspective and also a cultural perspective as well.
Yep, absolutely. All right, very good. Pete, what are your thoughts on why is it so complicated?
Yeah, so following from those points about it's essentially an integration point for a lot of things across a company, which means that it's a shared environment which has user access, privileges, setup issues. We've got simultaneous access issues between users who are consuming the data, the different users consuming the data at the same time, but also contention between things that are writing into the system and versus those things that are consuming the data. users might be creating their own content. Again, it's all outside of the or outside of the formal controls that you might have on that system in terms of its structure, and all of that stuff then augments all of those problems that you've got with essentially the state of the database. So, so as Robert was saying there, you can't just like blow that stuff away and replace it. Even if you did have good standard patterns for version control and for deployment and for user creation and control, which we don't have universally adopted, you know, you'd still have that problem of there's all sorts of things with all sorts of contention changing the state of that database, adding to those problems there. You've also got problems to do with databases can be bigger things to deal with than the kind of environment that you could run a small use case or integration test type tests in. For the reason that large databases can perform quite differently from small databases. So it can be difficult to get complete information in a timely manner. Tests can be slow, and it can be also more expensive to do the kind of information gathering that you want there. There's also lots of different types of databases, which sometimes projects can start out assuming that those databases are similar. They're like, oh, well, you already did this on Oracle. The client wants a SQL Server version of that. How about you just crack on with it? You know, that quite often doesn't work out the way people are expecting. Then you've got good techniques for dealing with some of that stuff that can help, but I think we'll get to that later in the show, won't we? But you know, that's a problem that you can get there. And then there's also the fact that you've got like a coupling of code with the structure and the data in the database. So for instance, people are creating like procedures and triggers and things like that. Sometimes it's tightly coupled with the programming that people are doing. Sometimes that's appropriate, sometimes that's not. Where it comes back to looking at Conway's law on that one as well. So all of that stuff together, yeah, definitely makes databases complex to deal with.
Complex to deal with, yep. And the fact that they're so central to the proper functioning of those applications, and that the data, we talked about this a little bit last time, the data that's in there is so important that you can't, you have to be pretty careful with that because you don't want to mess up your online actual data that you're working with. Absolutely. All right, great. Himanshu, how about you? What are your thoughts? Anything to add?
Sure. I mean, I think the major points were already covered, but I would say that the biggest thing that I've seen in my experience has been those database-specific nuances. So there are some general best practices that you can apply to tackle a lot of this complexity, and I'm pretty sure we'll get into those. But anytime you try to design the solution and get into the technicalities, a lot of times you end up usually implementing something very specific to a particular type of database. So that's one of the other additional challenges that I've noticed in my experience.
Is that they're all snowflakes?
Exactly, and in general, you want to implement generic solutions and best practices, but sometimes it seems a bit unavoidable. Right,
and it's compounded by there's lots of different kinds of databases. There's Oracle and
exactly.
You mentioned those. You've got built-in databases on Amazon that people may start working with. RDS,
exactly.
Right.
Exactly.
There's a whole host of different ways for people to store this information that may or may not be sort of better architecturally or easy to manage. These are trade-offs that people need to make.
Exactly, and in some environments, you may even have multiple types of data stores, and that further compounds the problem.
Right, right. As part of one application, you're saying?
Exactly. Usually, it could be a bunch of microservices, or even some monoliths may use, multiple data stores.
Yeah. So my recommendation, I'll just put this out there, is you should write everything to a flat file. Just use that.
Exactly.
All right, very good. I'm just kidding. You should not say anything that I ever say. Brady, what are your thoughts on this, the complexity in the database?
Well, I think a lot of bases have been covered here, and good and very well at that. One of the things I just wanted to underscore was that you mentioned the level of risk in change processes with databases, and what that's led to is a culture of database change that is at the sort of nominally being very careful is actually turns out to be a little careless, because there's this overemphasis of process to avoid risk that means that things are done in a bespoke manner, and it makes it difficult for to bring something as regular as automation to it. The other thing that happens is because because of the risk and because it gets into this culture of wizards, there hasn't been a great deal of thought into, we've had all these revolutions in software development methodology with regard to like object-oriented and functional programming, all these things. A different style comes out every couple of years, but where is somebody saying this is the bright line in the way databases should work? This is how much business logic should go into a stored procedure versus into your object relational code above it. And it's that very blurry approach to how the database is actually utilized that I think creates a lot of complexity in bringing in a tool or automation approach to it.
I think that's a really good point, and I think it applies to much more than just sort of databases. Anytime you get to a point where you understand a problem well enough that you can be really prescriptive about a solution to it and have it work 80% of the time, you'll find a lot of people will just be happy to get, hey, you know what, it's vanilla. I'm happy with vanilla. I don't need chocolate. I don't want pistachio. I don't need rum raisin. I'm good with vanilla. I would like some sprinkles, or I would like some chocolate sauce. But at the end of the day, it's vanilla. And so it goes with fruit, it goes with sprinkles, it goes with everything. And so making that sort of more mainline, more streamlined, and more generic and non-bespoke you can make things, I think, the better.
Right. There's a scale of change. I mean, if you just sift, 1,000 changes to somebody's database, 90% of them will be accretive, meaning you could remove them or add them with no impact on the database. But it's that other 10%, or if your company does 20% destructive changes or transformational changes, then you're really into a realm of like lots of risk, in trying to speed things up.
Right. I don't know if you guys can hear it, but there's like an army of motorcyclists with loud music riding past our office. Maybe you can't hear it.
No, I can hear it.
Oh, it's pretty quiet. Yeah.
All right, good. So Anders, bring it home for us. What are your thoughts on the complexity of databases as part of this whole process?
Yeah, I mean, as usual, our panelists have taken all my good points. I mean, I think it's interesting. We were talking yesterday about loosely coupled systems, getting ready for a webinar, and really the RDBMS, when you're talking about things like microservices and so on, is I think by far the largest source of coupling that we have when we start to kind of tease apart monoliths into microservices or more loosely coupled systems. And really, I think the RDBMS has kind of become I was going to say it's become a crutch, but that's kind of the wrong word. I need to find a better word there. But it's the thing that we go to solve a lot of problems that in the end sometimes causes problems for us. Mostly through coupling and those kinds of things. And then the other thing that makes it difficult is there's just a woeful lack of standardization at the API level. Across databases, we've got SQL 92, and we've got some fairly decent standardization on the query side of things. But when it comes to schema manipulation and DML or DDL, there's really a lack of standardization. Some databases support transactions on DDL and some don't, and that's insanely infuriating for those of us that have to support multiple databases. For our customers, different database vendors, I should say. Now, the fact that there is this kind of lack of standardization, there's kind of it's a double-edged sword, right? Because the bad part about it is, there are no standards, and it becomes very difficult to kind of do a one-size-fits-all pipeline for this kind of stuff. The good part about it is that's also where some of the innovation comes. So, for example, Oracle with their snapshotting functionality, which I think will show up in other vendors as well, has been a kind of a good thing for people trying to do upgrades on complex database systems, because it gives you a very nice rollback mechanism that isn't necessarily a full, you don't have to go do a full restore of a backup. It's a much more lightweight kind of thing to do, not necessarily lightweight, but more lightweight. So that's kind of a pain. And then databases are difficult to tune, and again, that kind of shows up in There's a lot of kind of magic knowledge that people have and folklore. And again, it can be infuriating when you're dealing with multiple database vendors, because literally, we've run into scenarios where a change that we make to tune something for one database vendor has the opposite effect on the other database vendor. The most concrete example I have of that is that SQL Server and Oracle, their optimizers treat string constants very differently. If you include a string constant in a query, and I forget which is which, it'll make it really slow because it won't use indexes on the one database, but really fast on the other one. And if you instead change that to a parameter, it has benefit on one, but pain on the other. So it's one of those things where it's just not as straightforward as you want it to be. And that, I think, just kind of the coupling, the lack of standardization at the API level, the sort of all the magic knowledge that you have to have, that is written down on Post-it notes, stuck to the bottom of drawers all over the world. Those kinds of things. It just, it is a critical piece of technology, but it's probably also one of the most problematic ones when it comes to doing continuous delivery and DevOps and those kinds of things.
Yeah, it's interesting. You mentioned this earlier. We were preparing for a webinar. We do have a webinar coming up with Jez Humble. Any of you out there listening, Jez Humble's the co-author of many books, including the first book on continuous delivery. And so Anders was having this exact conversation with Jez about how do you sort of untangle all this code and make it more loosely coupled, and it is a serious problem. One of the things that you mentioned, I'm getting to a question, one of the things that you mentioned in that conversation, Anders, was maybe you move away from a DBMS, RDBMS, and you move towards something like a NoSQL or something else. I don't know if I'm jumping ahead, or if this is something where can those things help solve these problems for people and solve some of that complexity, or does that add more complexity because it's
I think, yeah, it's kind of all of the above, I think, because certainly if you move away from RDBMS, you can use kind of less coupled storage mechanisms, like S3 or key value or Redis and all of these kinds of things. But the tricky part with that is then you have to attack and determine what your consistency requirements are. If I'm doing a shopping cart where I'm doing, credit card transactions and those kinds of things, I probably have different consistency, kind of requirements than if I'm doing, updates on Facebook. If updates on Facebook come out a little bit slower for one person than the other, no big deal. If my bank and I disagree on the nature of the current, amount or balance in my account, yeah, that's kind of a problem. So again, it's the right tool for the job, and I think databases have become, RDBMSs have become the go-to because we're already using them for quite a bit of things, and then it becomes very tempting to just throw everything in there, and then you start to put, foreign keys between all the various tables, and now you've got more coupling and all of those kinds of things. So it's a lot of it is just with this in mind. I think if we were to go back and look at a lot of applications and kind of architect them from scratch, not that we're ever actually allowed to do that for real, but we would do it differently. I think all of us probably have stories of where, oh my God, that was the wrong thing to do and we should have done it differently.
Like the one-page method.
Yes, no more 4,000 line methods, please.
Hey, what's wrong with that?
Yeah, exactly.
There's I do hear this a lot. We have moved to NoSQL away from a relational database, so no problem. The challenge is that at companies that, for example, use Cassandra, they will just because there's no schema doesn't mean that there's no structure. And so they are making changes to that underlying structure in Cassandra using CQL, Cassandra Query Language. The same challenges that exist for SQL, environment inconsistency, making sure that it's going to run, making sure it's syntactically correct, exist for CQL as same with SQL. We have challenges around Mongo and other document stores about updating all the documents to adhere to the new application release. All right, that's great that, you know, that there are applications for NoSQL, for document stores, those sorts of things. However, you are still going to have challenges around change. It's different change, but it still exists, and you still have the issue of dealing with state. That's the big challenge.
Couldn't agree more. Couldn't agree more.
Yep. Right on. Well, let's get into some of those challenges that we were just talking about. What are some of those challenges that we have with releasing updates to the database and doing that at large scale? And we're going to start on the other side. We're going to start now with Brady.
So one of the, I mean, well, first off, again, there's this challenge of a recognized or generally accepted consistent process for doing those type of changes. I mean, I would say that people are pretty well settled on a script-based process, that you push scripts from one environment to another, and then those scripts would would affect your database change, and yet there's all the challenges of mixing your DDL, DML, and there's the challenges of destructive versus accretive changes, and then there's the whole problem of how do you deal with source control and ordering and dependency. And it's one of the other thing is that you've got this, you know, they're written by people, so they're not necessarily 100% accurate. And have they been run through a previous environment that is in any way consistent with the environment that you're about to run them against? So all of those really come in as factors in the success of your deployments. And then speeding it all up, you know, there's many times there's a going rule in your release process that says, oh, we have to take a backup beforehand, and that might be a 3-hour process, 4-hour process, and there isn't really a good rubric. Well, there's a rubric, but there's not a generally accepted practice for evaluating what changes would be safe to do without a backup. And who's going to sign off on that, you know?
Right,
so,
and
yeah,
that's the thing, is that they all could be safe, but the guy who says, oh, it's fine, let's go ahead and do it, that's the guy that'll get fired as soon as some shit happens. So,
well, and that's why
exactly.
It's like asking permission for lawyers. They're highly incentivized to say no.
That's right. Yeah. And that is, I think that's one of the big challenges, is that critical nature of that data. It's just so important to these people.
Yeah, I mean, you know, often the data in the database is the core asset of the company.
Right.
Whether it's you know, ad data or commerce data or what have you, it's, you know, that's a significant percentage of the assets of the company, and you know, you don't want them to go down because you have bad backups or, you know, those kinds of things. Or, you know, as a friend of mine always says, you know, it's not your backup strategy that's important, it's your restore strategy that's important.
Yes.
You know,
That's right.
and if you don't test your restores, you know, it ain't gonna work. You know?
Yeah. I had I won't
tangent there.
Yeah, that's fine. Okay, very good. Brady, anything else?
Oh, I didn't want to drain the pond for everyone else, you know.
Oh, okay. So, that's nice. We can always come back around.
Yeah.
That's very nice of you. All right, so let's go over to Himanshu. Himanshu.
Sure. So in terms of the challenges, I think this is like anything else in CI/CD and DevOps. You have the challenge from the people aspect of things as well as the technical side of things. So if you look at the people side of things, then especially in larger enterprise environments, you tend to have those siloed DBA groups, and in some cases they are distributed across multiple geographies, where they are either managing their databases across these geographies as well as trying to coordinate changes across multiple individuals and teams across wide range of geographies. So that's one challenge you have. And on the other side, in terms of the technical side of things, obviously we've touched upon some of the challenges, but in addition, if you look at some general best practices in CI/CD, you need the ability to spin up dev test environments very easily. And what you'll find is that this is not a common practice when it comes to database, as well as the tooling is not as mature. So that's another challenge that we see consistently happening all of the time.
So you're saying, I want to interrupt you. So you're saying that spooling up test environments is obviously something that lots of people do. I'm sure lots of people would want to do it more effectively. But what you're saying is that when they do that, they're not spooling up a new database to test with. They're using some.
They have a shared environment.
One that everybody sort of connects to.
Exactly. And from the business side of things as well, the concern they have is that even though the technology might exist, the concern they'll have is that, hey, we have compliance needs. So we can't just give you like a copy of the production data. So we need to anonymize some of the data. We need to do some cleanups, and all of that part, if it's not automated, then becomes a major impediment overall. So frequently, what we find is shared environments used by DBAs, by developers, and that again becomes a bottleneck overall for the rate of change and trying to avoid overstepping on each other.
Right, and having a solid process around how do you promote changes to that environment when people are like, well, I'm just going to test this and I'm just going to go do this, and all of a sudden you get like, what the hell is that now? That's
you're not making deterministic changes, or sometimes you don't even know, the changes that are being made and promoted, which is a scary prospect, but does seem not very uncommon, sadly.
Yeah. All right, interesting. How about you? Anything else?
I think those were the main points. I'm sure we'll hear the rest.
Very good. All right, Pete, what are your thoughts?
Yeah, just following that point Himanshu was making there on changes, like lots of environments and stuff like that. We've got quite a few environments where you have to have equivalent databases, like multiple copies of the same database structure, and that you share data from one of those databases to another. So you really need stuff to keep those in sync. You don't want to be like adding a column or changing a data type on one of those databases and it doesn't match on another one of those databases. That will cause all sorts of disasters. And some of those little changes, you want to make those like really quickly, and you want to make sure that if there's any kind of urgent changes that you need to make to the database, you don't have a different process for your urgent changes versus your normal changes. So if your normal change process for the database could be super fast. We had one place where we got about 3.5 minutes on the stopwatch from making like a trivial change and deploying it. Just meant that no one would ever put the pressure on us to just go in and make changes to the database, because one of the problems we've found, I think, is that though databases like they can be big and heavy, there are these integration points, all sorts of things going on in there, that your client's senior manager probably feels like he understands what a database is and can order you to go and change it when it's important to go and do that. Whereas if it's some like new scripting language he's not heard of, might leave you alone on that stuff. So I think it's really important to have an urgent change process that you can just implement that stuff super quickly.
Nothing ever goes, just so you know, nothing will ever go wrong if you're doing something in an urgent manner. Everything always goes very smoothly.
Well, that's it. When people are yelling at you, that's the time when you want to have all of your audit and stuff turned on. It's not the time to turn the audit off when you're in a hurry. Speaking of which, rollback and stuff like that, I've been in a few conversations with people where they're like, oh, you don't need rollback, we just roll forward. And I'm like, what you mean by roll forward is making it up as you go along. That's what you mean by roll forward. Like under some circumstances, a roll forward of a tested thing is a good thing to do. But when people just say, oh, no rollback, just roll forward, if they haven't figured out how to do rollback, they don't know how to do a proper roll forward. So they basically don't want to do that.
And that's interesting because that's very different than with an application, right? Because with an application, the application is sort of stateless when it's not running. There's no state. So if I make a change, if I deploy version 2, and then I say, well, I really need version 1, so let me just rename version 1 to version 3, and boom, now I've got version 1 again. But on a database, if I say, well, you know what, I'm going to add this column, and then, oh, you know what, I really don't want, I'm just going to go delete that column. Yeah,
exactly. So I mean, we've got the section on patterns later, so which we'll get to things to talk about on that. A problem that we've had is you've got all of the structure in your database, and then you let users like ad hoc analysts, data science type people go into the Redshift cluster, and they go and create their own views and stuff like that. Then when you come along with your sequential automated process to go and like rebuild the table and do something, it goes, well, someone just created a bunch of views on top of that. And we had a few interesting conversations on that recently, because we were like, should we have sophisticated functionality to capture those views, capture the definition of those views, be able to rebuild the tables that are underneath them and put the views back in place? And we actually came to the conclusion that that'd be neat functionality for some some instances. But we've actually thought that maybe it'd be better to get the clients on board with defining their views as part of our process for the proper sequential source code controlled version of the code, and solve the right problem instead. So I would say if you feel like you're figuring out a deployment process and it's getting super complicated, then maybe you've got some kind of a workaround going on in there, and that's. Yeah, that's it. It shouldn't be that complicated, because then it gets a bit risky. I've been told recently to do dynamic changes in production, and I said no. I was wondering who's going to watch this. Probably not those guys, maybe. But basically, just imagine Kafka queue. Lots of messages coming through in there, and just like looking at what's coming through, and then just like deciding based on the message that comes through live that you're going to then just kick off some alter table statements as a result of that, just completely live with no testing on what it would end up like. I mean, there's maybe some like subset example type things where that kind of thing would go wrong, but there can be like quite a tendency for people to think, well, I just need to alter that table. I just want it to happen when it needs to happen, and then kind of throw away the concept of versioning what it is that you're going to deploy, so that you've got control of when you're going to be able to deploy it, and also being able to test it as well. So we're working on kind of a solution where we get all of that automatic detection of what we need to change to the database based on some other systems that we're interacting with, but we're doing it at development time, so we can test it all and capture it all. So that'll be interesting blog post if I get around to writing that one up. Yeah, just a couple other things on there. So like reference data management approaches, there's always lots to look at there. And also when to use your gold standard processes like Kimball dimension modeling. Sometimes people won't agree on when to do it, when not to do it, that kind of thing. And then there's lots of things to do with like processing problems. Like if you've got lots of different databases, it's no good having somebody like go through all of these audit tables to say this job ran at this particular time, therefore do this, and like going through all of these IDs and looking things up and stuff. If you can define things to be like more idempotent in operation, then you can just go, that failed, hit the button again, or automatically retry, and it kind of can sort itself out. And historical data reload, processing, data reconciliation, and stuff like that. And then
it's much more fun to just be able to say, here, do that again, as opposed to trying to figure out what actually went wrong.
Yeah, well, sometimes that's what the boss says, isn't it? They're like, try again. And you're like, okay, that's what I do. No, exactly.
Just try it again.
Yeah, exactly. It's like, I'm getting this treatment right, or I'm going to take it out on the database now. It has to try it again as well. And one of the guys made a great point about looking at your the way you're using, depending on what type of database engine you've got, it's going to respond differently to things like high volumes of small commits, whether you're like read heavy or write heavy and stuff like that. And you can have like, there's usually a tendency to underestimate the amount of time that it's worth spending looking at that stuff to get that kind of thing right. So, I mean, those are just some examples of challenges that can be assisted by having some DevOps approaches there.
Lovely, right on. All right, Pete, thank you. Robert, what are your thoughts on this? What are some of the challenges that you see?
Well, yeah, the biggest challenge with database change at scale is that for so long, the rate of change for our application releases has increased exponentially. We are purchasing, ARA solutions like Electric Cloud to automate a lot of the stuff that we were throwing bodies at. But we are still relying on manual changes. We are still relying on the world's most advanced computer, the human brain, to evaluate all these changes at every single point. Now, back in the day, we had a lot of challenges around this. When we started, even before the DevOps term was there, when we started having continuous delivery and those sorts of things, people wanted to be there. No, I've got to run this. I got to watch this script run to make sure it won't blow up. But we got better. All right, we were able to automate these things. And so if we continue on this path of increasing the rate at which we release the application and the rate at which we release database changes linear, we are going to have a bottleneck at scale. We will never be able to reach the promised land of DevOps unless we automate the entire part of our every part of our application. So to address the scale issue, it's very simple. You need to look at every point in your release process and identify where it's manual, where there requires somebody to look at two screens and make a compare, to make a decision, to get involved. No, 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 no. That needs to go away. You need to have complete automation. And what those database administrators wind up doing, instead of being there, glorified help desk folks, they are now tasked with things that really increase the productivity and the value of the company. I mean, remember, the State of DevOps report a couple years ago stated that companies that adopt DevOps have a higher market capitalization and outperform the S&P 500. And I read that and I said, holy crap, the geeks won. This is the first time where we can say, oh, look, if I go and do this thing, I'm going to increase the value of the company.
Business impact, yeah.
Absolutely. And so we need to get away from this idea of these silos. We need to get away from, oh, no, you can't do that. Oh, that's for somebody else. No, 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 no. Away from Conway's Law. We need to get away from these silos, cross-functional teams, distributed data management. Why do we have to go and talk to this person to make this happen? Why do we have to do it that way? The Toyota 5 whys. Every time you have a challenge, you got to ask why? And the answer for this will always come back to, we've always done it that way. And that's when you make a change, right there.
Yeah.
That's how you get scale. Look for friction, eliminate it, lather, rinse, repeat.
Continually improve. Absolutely.
Yep.
Very good. All right, Anders, what are your thoughts on that?
Well, yeah, I mean, I think the idea that performance is important is kind of core. And I don't necessarily mean performance at runtime. Really, I mean performance at change time, because that's going to have a pretty big impact on your cycle time if you have to make database changes as part of your rollout. And this is one of those areas where, I'm probably going to get a little bit of crap for saying this, but you get what you pay for currently still. If you're running a lot of the free databases, not all of them, but I'm going to throw MySQL under the bus today. If you drop an index in MySQL from a table, it rewrites the whole table from start to finish. So in order to remove an index, that takes a long time, and you can only remove one at a time. We had a schema change we did a few years ago where we needed to drop 9 indexes from a pretty large table. Now, shame on us for not knowing this ahead of time and not being as facile with our tools as we should be. But drop 9 indexes, rewrite a huge table 9 times just to remove information from it. That's to me, that makes MySQL not a production-ready database, right? It's great at inserts. That's basically all I can say about MySQL. I'm still a little bitter about this experience, as you can tell.
Oh my God.
I bring it up every chance I get.
I can imagine we're going to get a letter.
Yeah, I'm hoping someday some MySQL engineer will hear me and go, oh, I know how to fix that.
That'd be great.
Certainly it's gotten better over time.
Helping, that would be wonderful.
Yeah, I know. The other, or they would probably just say, well, you have the source code, why don't you go fix it? Which is a fair point. The other thing you have to deal with that makes things tricky is privacy and governance and HIPAA and those kinds of things when you're dealing with clinical data or health-related data or other kinds of things. Some of the pharma companies that we've worked with over the years, one of the tricky things for them to do things like just plain old self-service deployment of applications and data is complicated by the fact that where you can deploy that data changes based on the structure, the nature of that data. So, if it has health-related HIPAA covered data, they did not want to deploy it into the cloud, the public cloud. They wanted to keep that inside the firewall. So now you have this big kind of fork in the road for deployments where some things can go there and some things can't go there. So already, the nature of data, and it's not fair to blame that on databases, right? That's not the vendor's fault. That's just the fact that we have data that's, privacy protected. We need to cope with it, but it shows up when we want to make changes or when we want to use that data. And that's, that's really where it comes down to. And you really can screw yourself pretty badly if you don't architect your data correctly up front. And we've done that ourselves. When we first started out with the Electric Flow product, our keys were integers. And when we made the transition from a single server environment to a clustered environment, we had to make a change there to make sure that we weren't reliant on integer keys, and also weren't reliant on sequences in databases, because not all vendors support sequences or support them in the same way. So we made the switch to using UUIDs for our keys. Well, that's a rewrite of the whole database essentially. And you know, we had customers that took a week of background running to migrate that database. Now, not a week of downtime, because we did it so that we could do the upgrade while we're still in production. But that was a lot of work. And so the challenges are deep. The challenges are kind of fundamental if you make a mistake starting out. And all I can say about that is, the earlier you fix that, the easier it's going to be. When it comes to databases, I often pull out my tractor pull analogy, which is, if you've never been to a tractor pull, the one thing you need to understand is you need to pull that sled as quickly as possible, because the weight on the sled is moving closer and closer to the kingpin. And when it gets over the kingpin, you will bog down. You will not be able to go anywhere. So the point is to get as fast as possible, because at the end, you're going to get bogged down. I feel the same way about databases. The sooner you can fix your problems, the less data there is in the table when you fix the problem, the easier it's going to be to fix. And there will come a point where there is so much data in your database that all the fixes are bad. All your options are bad, and you just have to choose the least bad option.
Well, Anders, that's the Chinese proverb, right? The best time to plant a tree is 20 years ago. The second best time is today.
That's okay. I'm going to steal that. I'm going to steal that anecdote or that phrase, because that's perfect.
Yeah. Awesome. All right. So moving on to the last and final topic: patterns for DevOps for DBs, for testing, for deploying, for rollback, for whatever. What are some successful patterns that you guys have seen to help people manage this complexity with their databases? And I'll start with Himanshu.
Sure. So in terms of helping automate this whole process of being able to make deterministic changes and promoting those across different environments, typically you'll need to look at some existing tooling out there that might be able to help you. So there are a whole class of tools called database lifecycle management tools. There are some commercial tools and open source tools. Teams should do their own evaluation and figure out what works best for the database they're dealing with, as well as the overall process that they're dealing with. And then they need to incorporate that into their CI/CD pipeline. They need to regard database as yet another change, as part of the standard part of the pipeline. And like any other general best practices in CI/CD, you need to be able to make changes. You need to be able to sometimes collaborate on changes that need to be reviewed by your peers, and then instantly promoted. And as part of your pipeline, all of your standard tests should run. If you have the option to do some database specific testing, those should be part of that as well. And then obviously we talked about some of the other peripheral topics, like in some cases you need a way to be easily able to add additional dev test environments as needed, ability to synchronize them, ability to periodically refresh them with the data from production, but in the end still meeting those compliance needs that your organization has. And then on the process side of things, once you want to target these sort of more rapid changes, on the process side of things as well, you might have some impediment, because some organizations have some very unnecessary levels of change control around databases, where they may say that, hey, in order to add this column in a table, we need 3 levels of approval. And then when you're deploying it to a test environment, you again need the same levels of approval. And you ideally want to eliminate those. Obviously, it doesn't mean that throw change control out of the window, but you want to have a good balance between having the ability to make these changes in a rapid manner while still meeting your compliance and change control needs in the organization.
And Himanshu, would you say that the more practice you have, and the more to Robert and Brady's points, the more sort of automation that you can bring to this party, the more ability you get, then it makes these changes not as scary, and you can do them more often. Isn't that the whole thing about?
Exactly. That's the whole thing about DevOps, the whole thing about CI/CD. Make changes early on, things, ship things left, break dev early on, and then break the test less frequently, but anticipate them, and then hopefully that will help you break things less once you move to production.
Exactly. That's right. Okay. Yeah, Brady, your light went off. That was kind of You weren't
Must
moving
be too
your weapon.
sedentary. I'm not animated. I'm not talking enough. Huh?
Be more expressive. So Himanshu, were you finished then? I'll go over to Brady as long as he's begging.
Sure. I think those were the major points, and I'll let the rest of the folks add theirs.
Fabulous. Thank you, Himanshu. All right, Brady, since you were dancing around, why don't you go next?
Oh, certainly. We can't underscore automation enough, right? So we've got to work through that. But I think that the behavioral hurdles are the thing that we're having to embrace. And I say embrace because I don't just say we got to get rid of them, because what it is that the people whose neck is on the line when database changes go wrong, they need assurance, and they can stonewall anybody's plan. So unless you can make it friendly enough for them, unless you can give them the assurance that you have, reasonable analogs to production, that you can say, because the automation worked here, it's gonna work here, I guarantee. And it's that whole process of assurance that's really key in this. And the way in which you get that type of thing is by not just repeatability, because you might know it works, but you've got to be able to show it as being statistically repeatable. So you need to look across your entire pipeline and say, we've made 746 changes, 687 went without incident, 42 were repaired within 15 minutes. It's that type of thing. And unless you can bring those numbers to bear, you're just not going to be able to get the sign off. Yeah.
Trust me.
Yeah. I've got a really great idea. We talked about it all night.
So cool. Little Tommy drop tables. He taught me.
And so for that, tooling is really important, because unless you've got a process that allows you to capture what's going on and capture it at all levels, so that you can say, not only do I know how many deployments I made, and I know how long they took, and I know what went on here, but I also have to know that the environment I'm approaching is in a state that's ready to receive this deployment. And that has to do with understanding all the sources of change. I think Pete mentioned in one of the previous questions about that there's so many constituents who have access to your database, whether it's a set of DBAs on a different continent optimizing things, whereas your developers are making these changes. Unless you coordinate that into a cohesive package to move forward, then you're not going to have good results down the pipeline. So I think that's that pattern of building things for consistency and then demonstrating that consistency and advertising it and getting it out there is what's really going to make an implementation successful.
Yep, giving people that comfort. All right, Robert, what are your thoughts on some patterns to be successful?
Well, I think every single pattern that you've seen that has had success in DevOps for the application, you should apply that to the database. Period. There is no other, there's not anything unique that's going on here. All right. So for example, the pattern of parallel change, where we expand, we migrate, we contract. So we add functionality. We wait to the database. We wait until, for example, if we need to rename a column, we can add a new column. We don't rename it. We add a new column, and then we use things like triggers to maintain data synchronicity. Then once we know that nobody is using the old column, well, we get rid of it, all right? And that's part of that migrate and contract, all right? So migrate, get all the software, the application no longer using it, and then it goes away. That is a pattern well established in microservices. It works. It works amazingly well, and we need to apply those patterns to changing the database and bringing DevOps to the database. I also think that leadership is a huge pattern, okay? That having individuals that will ask that question, why, get to, we've always done it that way, it proves the necessity of having inspirational leaders like Steve Brody around. That really, I'm doing that because I know he's watching. He's liking all these tweets.
He's actually standing right out there in the hall.
Oh, he is? Shout out for Steve. But look, leadership is important, okay, to be able to break glass and to be able to say, hey, look, guys, I get it, all right? You were told for the past 20 years, pay attention to the database. Don't let any change. Well, guess what? We're changing a lot, all right? We're moving to microservices, the cloud, DevOps, whatever is next. Get used to it. Change is here. So instead of stopping change and wrapping it around process, facilitate change. Allow it to happen.
Yeah, embrace it, and but yeah, safe, right?
Yes. Yeah, you can balance both. It doesn't have to be a pendulum swing. We can be in the middle.
Yeah, as long as people are comfortable with that pace of change, you want to allow velocity without getting rid of the safety. Is the
well, true, but you can have both, right. And sometimes you have to have a balance between the two. You can't let one side or the other win. Build a bridge, get over it.
Yeah, absolutely. All right, great. Pete, what are your thoughts here? Some patterns that you've seen that have been successful.
We're getting a fair bit of mileage out of looking at the structure of the database versus the reference data that goes into the database versus the regular feed data versus the user management aspects. Looking at those 4 different areas of the database and figuring out, do we have a solution that we can use to cover each of those things? They depend on each other a little bit in some kinds of ways, but I think Brady was making a great point on the auditability there. If you want to be 100% that you've got all of your changes covered, then you might be in a situation where you can get 100% of your structure changes to the database in the kind of to the kind of automation process that you want to have, but still some people are going in there and doing some manual changes to the actual data itself. Maybe it's just like the maybe it's like some reference data and people are allowed to update some descriptions themselves and stuff like that. So I'd say having that kind of separation can allow you to break the problem down a little bit, and then you're much more likely to be able to succeed at one of those areas. But there's kind of a balance there, because you could declare victory at one point. You haven't really, unless you've covered everything.
Mission accomplished.
Yeah, exactly. Yeah, let's jump up and down on the aircraft carrier. Yeah, so Hemant was mentioning database lifecycle management tools. So we use those here a lot, and the automated tests on the structure of the database that those tools put in place can be quite handy to just get around the whole that super basic test when people are like, is the table there with the right columns and stuff like that? You can have that as an automated test, just reading the system catalog of the database. That's a super easy test to do, and it's just great for demonstrating that you've got what you expected. Because if there was some kind of failure, the kind of failure where you don't get the error message that you're expecting, that stuff is still going to tell you that you've got the structure of the database that you were expecting. And you can also augment those a little bit to check if there's anything in the database that's not meant to be there, because that stuff can catch you out as well. We had a great presentation by OLX at last week's Redshift meetup in London, and they were talking about how they've got multiple Redshift clusters and how they have one big heavy one where they do the processing, and then they have techniques for getting publishing the data from that processing cluster into other clusters where they actually read the data. So that's a thing that we've done as well. And we use the big magnetic nodes with loads of data on there to do the processing. I had some small SSD nodes to do the querying because we needed a different profile and stuff like that. So there's a lot of techniques that you can do in terms of publishing data. Like you can publish data out to S3 and then subscribe the data from S3. And if you have a good set of thoughts on how you will partition that data down so that you can only publish the bits that need to go out, and then you can have your clusters that are subscribing be a bit smart in terms of what they need to bring in. You can have some idempotent operation there, deal with some really big volume changes, and it's super easy to set up your test environments as well, because you just go test environment, get the last month's worth of data, and it'll go and find it for you, load all of that stuff up. You just kick it off in the evening, and the next morning you're good. So I say that kind of federation type stuff is super good. Establishing data quality stuff that's realistic is a super important thing, because sometimes you're making all these contracts with people who are going to send you data, and they're saying, oh yeah, we'll send you the data, yeah, and you're like, this feels like it's a manual process every day just to check which way they managed to screw it up this time. And so sometimes it can be, you want to like just acknowledge that you're going to have to go and put a deduplication step in and have them send the data twice or something like that. You know, there's things like that to look out for. So I'd say always reserve time for people screwing up the data that they're going to send you. A handy thing that we've done is, it seemed like a bit hacky to start with, but then we found it to be like quite awesome actually. Is we just like Jenkins for like everything that we could think of, and when we needed to like run some queries for something on the database that wasn't in the area that's got lockdown control, like the sequential control, so we're like running some kind of test or something like that. We didn't want like people in SQL Workbench just running it off their laptop and then it would time out and no one knew what was going on and stuff. But we just like in Jenkins, like put the query in there. It just like seemed really hacky to start with, but then we were like, well, this is great. I just go in there and I'm like, oh, Neil's running this thing, you know, just it's been running for 4 hours. I'm on Slack and like the thing is still running, and he's like, oh, that doesn't look right. You know, it's like a great way to
Alexa. And then you can have it all be totally hands off.
Yeah, that'd be great. I mean, like, Alexa, cancel Neil's queries and run all my stuff. Testing stuff. We use Fitness, which is like really mature, maybe not the trendiest framework anymore, but it's got this great DB plugin called DB Fit, which is just brilliant for people who are very database centric because it's got a nice GUI, so you feel like you're just like dealing with a wiki type of a thing. It's you write your tests by writing a SQL query and then putting a grid of results. And so it's like it's really how database people think. They're like, if I ran this SQL query, I would want these results to come back. It's a nice, easy GUI and stuff like that. And you just like press the test button and it like colors in the grid of results, red or green for whether it matches. So I'll say DB Fit is brilliant. If you've got database people who are not used to testing, you can get them started with that stuff, get a lot of benefit for that. Plays nicely with Git, that you can put the test definitions into there. Plays nicely with Jenkins as well. And it's quite easy to write your tests so that you can have them work in a kind of passive type of a way, just like compare this figure with this figure, and then you can run those tests on production environments without messing anything up there. There's lots of things you can do, like testing loaders. You can set up the text file of the file you're trying to load as though it's a text-based database, and query that and then compare it to what it looks like when it's been loaded into the database, and there's all stuff like that. DB Fit, definitely highly recommend that. And cloud, all of the cloud solutions that you've got for your database problems, it also just tends to get easier when you're in the cloud. It's like, well, I want to have another environment. It's like, I don't have to schedule clearing down one of my test environments and the hardware that's in the data center and replacing it with something else. It's like, I'm going to clone that stuff and get a new environment there. Makes it a lot easier with DR, and sometimes you've got built-in features for that stuff as well. So that's my list there. Sorry.
That's great. No, Pete, that's great. Again, lots of preparation on your part. I appreciate it. Anders, we got 2 minutes left. Tell me, what are your thoughts on this? Besides, I think you said such smart things.
I think testing is one of the more kind of difficult things, and especially performance testing. Shift that as much left as possible, because the kinds of fixes that you're going to want to make in response to performance issues are probably not the kind of fixes you want to do right before you release or right before you deploy to production. Don't let engineers test with empty tables. That drives me nuts. I always want every engineer who's writing any sort of query code or any sort of database code is, what if there's a billion rows in this table? That's a question you should always ask. And then I think just sort of, it seems to me, just kind of summarizing a little bit, databases really in some ways is the most resilient and strongest silo left that we have to deal with. They're like the database people. And I'm not criticizing them as individuals, but they basically are the last people with veto power left in the siloing system, right? I mean, they're like the Russians on the UN Security Council. Niet, and really, I think we've won over developers, we've won over a lot of ops people, we've won over release people, we've won over QA people. I think that the database, at least in my experience when dealing with our customers, and again, this is not a criticism of the individuals, but the database function is still the one that's the most difficult to deal with, the most resistant to change, the most resistant to new tooling, all of those things. And I mean, for the same reason that we're all resistant to these kinds of things, right? They don't want to screw up and lose their job like any of us would be afraid of. So I think it's going to get better, obviously, but I think it is kind of the maybe not the last of the silos, but it's certainly the strongest of the silos still left. And we've got some work to do there, and I'm sure we'll as soon as we're done here, we'll get back to it.
That's right. Well, this has been a fantastic conversation. It's not a subject that I know terribly much about. So happy to learn from all of our panelists. Thank you all for joining us. Thank you, Anders. It's great seeing you. Good luck with the rest of your rewrite, and we will see everybody next week, 2 weeks from now, on another episode of Continuous Discussions. We also have one tomorrow morning, 7:30 Pacific time. 8 o'clock, sorry. We're starting at 7:30 to make sure that all the audio works, but it starts at 8. Thank you, Abigail. To talk about the State of DevOps report. So that's going to be an awesome episode as well, so look forward to seeing everybody there tomorrow. Thanks, everybody.
Thank you.
Thanks,
really
Thanks,
appreciate it. Thanks a lot, guys.